A continuously variable transmission known as a variator is abbreviated in international practice as CVT. Many drivers who have already tried such a system claim that it is very similar to a classic automatic. And this is not surprising because a CVT is actually a type of automatic transmission. In this video, we'll take a look at how a continuously variable transmission works, what features it has, what issues are most common, and how to properly maintain it. A continuously variable transmission is a mechanism that transmits torque from the engine to the wheels and can change the gear ratio smoothly without a clear breakdown into gears. Thanks to this solution, the variator provides gentle acceleration without jerking. It works quieter than most traditional automatic transmissions, allows you to optimize engine performance, which has a positive effect on fuel consumption. Despite all of this, the variator has its limitations. Its design is more complex than many other types of transmissions, which affects the cost of production and repair. In addition, not every engine can be paired with a CVT, especially if it is a powerful and highly boosted unit. However, every year more and more automakers are offering their own modifications of variators for a wide range of vehicles. To understand how a CVT works, you should first consider its key elements. Typically, a CVT consists of the engagement mechanism, friction with discs, electromagnetic clutch, or torque converter. It is needed to connect or disconnect the engine and transmission. Primary and secondary pulleys, they can change their diameter due to moving conical discs. Belt or chain, on some models, transmits torque from the drive pulley to the driven pulley. Control system, electronics, hydraulics, control units, and actuators. Reverse gear unit, most often a planetary gearbox because the belt or chain transmission itself does not reverse. The final drive and differential are standard elements that transmit torque to the wheels. The presence of additional mechanisms is explained by the fact that the CVT has to change the gear ratio smoothly and constantly. To do this, the pulleys need to be able to move in and out, and the electronics and hydraulics need to control the process precisely. In the modern automotive industry, the most widespread is the V-belt transmission. Back in the 50s of the last century, it was installed on some Fiat and Ford models. Later, most manufacturers developed this concept by offering their own versions of variators. Toyota calls its CVT multi-drive. Nissan produces Xtronic and Hyper. Mercedes-Benz uses Autotronic. Ford has gearshift CVT and Ecotronic. There used to be toroidal variators, Nissan's Xtroid, but over time they gave way to V-belts due to the complexity of production and less versatility. Different torque transmission mechanisms. Different components can be used inside the variator to transmit torque to the engine. Centrifugal automatic clutch, Transmatic. Multi-disc wet clutch, Multimatic, Multitronic. Electromagnetic clutch with electronic control, Hyper. Torque converter, Autotronic, Multi-drive, Lineartronic, Xtronic, Ecotronic, Xtroid. Many modern variators use a torque converter. Manufacturers already have extensive experience with such units. Their reliability and maintenance principles are well understood. The basic idea of a variator is to use two pulleys with conical walls between which a belt or chain runs. The angle between the discs can be changed, changing the effective diameter of the pulley. During acceleration, the diameter of the drive pulley increases and the driven pulley decreases, providing a higher speed. To get off the ground, a variator usually uses either a torque converter or a multiplate clutch. The control modes of such a gearbox are similar to an automatic, the usual P, R, N, D positions. Some manufacturers allow the driver to shift pseudo gears, for example 6 or 7 virtual steps, but this is more intended to remove the psychological barrier for those who are used to feeling the gear shift. Smooth acceleration and shifting. There are no jolts because there is no sharp gear selection. Quick speed up, no time is wasted searching for the optimal gear. Fuel economy. The engine can operate at optimal speed, low noise level. Compared to some types of automatic transmission. Environmental friendliness. Lower fuel consumption reduces emissions of harmful substances. High maintenance requirements. Oil and filters have to be changed more often than in automatic machines, and even more so in mechanics. Instability to overloads, prolonged driving at high speeds, or sudden starts severely wear out the belt and pulleys. Complicated and expensive repairs. Damage to even one unit can affect the entire transmission, and restoration requires special skills. Problems with driving on difficult surfaces. On slippery or uneven roads, the variator can quickly overheat or slip. Modern variators have become much more reliable, but typical breakdowns do occur. Belt or chain. Over time they stretch or wear out electronics, sensor malfunctions, broken contacts, damaged wiring, torque converter if equipped, or clutch system, the selector. It may give incorrect signals or stop working altogether. Oil pump and pressure reducing valve, worn out or dirty, causing pressure disturbances in the system, the forward clutch. Failure causes difficulties with starting and acceleration. If there are jerks, slippages, the car drives, even in neutral, or it is impossible to switch to manual mode, the cause may lie in both mechanical and electronic components. In many cases, a full diagnosis with the connection of special equipment is required. To ensure that the variator lasts a long time, the driver must follow a number of rules. Avoid sudden starts. Aggressive starting from a standstill significantly wears out the belt and pulleys. Do not drive at high speeds for too long. CVT does not tolerate prolonged maximum loads. Avoid slipping. If the car gets stuck, it is better to use the help of others or special equipment than to dig the wheels in the snow or mud. Avoid overloading the car and do not tow heavy trailers. All of this is especially important for owners of city small cars with a variator. They are great for quiet city driving, but they are not designed for extreme conditions or off-road driving. A continuously variable transmission is an excellent choice for a city car, providing smooth, efficient and comfortable driving. This unit makes the car quieter and the fuel consumption is lower compared to many other types of transmissions. At the same time, the variator does not like aggressive driving styles, requires regular and thorough maintenance, and its repair can be quite expensive. Although engineers often choose other options for powerful cars, such as robotic transmissions or multi-speed automatics, attempts to improve the variator are ongoing. So we can expect to see even more models with smart and reliable CVTs as technology advances, especially in the passenger segment, which is designed for calm and measured driving.